Alright, boys, I have kind of some bad news about the robot. Um, so basically, if you look at the design here, we need to do a pretty big design overhaul now because actually having made my first Archimedes down gear pulley system, which is this box, I had to make the box bigger because the actual pulley system is bigger than the design was, which was an estimate of how they would actually be. So this is the new upgraded, accurate size of my actual pulley system for the down gearing of the fingers, and it's a lot bigger than I had anticipated. And so, having resized it, we deleted all the smaller ones and just put in the bigger ones in the spaces that the smaller ones used to be. So all these teal boxes are where the pulley systems are going to go. You can see we only have one, two, three, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, 13 fit in the forearm. Now, each motor requires two pulley systems, one for its forward and one for its reverse actuation, unless the motor's handling just a single muscle, but not its opposing muscle, which happens sometimes in the human body is designed for my stuff. But the majority, especially for the hand, always has exact opposing muscle, except maybe some for the thumb and stuff don't have an exact opposing muscle. But for all the main fingers, it is that way. So, anyways, I estimated we probably need about 60 pulley systems to handle the hand. Let's go through that again. So basically, this forward and reverse and this forward and reverse will be one motor because we combine these two joints to be handled by a single motor. They'll move at the same time. So that's one motor, which requires two pulley systems, one for reverse and one for forward. So that's one. This forward, back, and side to side is two more motors. So that's one, two, three motors handles that finger. 6, 9, 10, 11, 12 motors. This one is going to be 13, 14, 15, maybe 16. And for the wrist, it's looking like maybe 17, 18, 19, maybe 20, 21. Just a rough estimate, maybe 21 motors. Um, let's just bump it up to 23, just for estimate. 23 times 2 would be, because it's two pulley systems per motor, roughly 23. Let's just say, okay, that'd be 46. So we need like ballpark for 40, let's just say 45 pulley systems in in the forearms. Because what I realize is if you have a motor here, right? Let's say we want this motor to be down geared, but we ran out of space for down gearing for this one. We can only have so many down gears, which is these teal boxes in the forearm. With these motors here, we've crammed every single one we can in here. We cannot fill this space with teal boxes because this is a crumple zone. Crumple zone means when the radius bone pronates, all this area goes like that when you twist the arm toward the body. All this gets squished as all these components swing over to here. So we can't put anything in that air gap. Um, so, anyways, we fit as many pulleys as we could in here. So let's say this motor hasn't been assigned one of these pulleys. It was for some of these other motors, let's just say. So it's like, okay, where do we put the pulleys for this motor then? Well, maybe we could put it in here. Well, let's say even that gets filled up. It doesn't look like there's much space for them. Maybe, I don't know how many, not too much. Even this is a crumple zone because that hits against here when the arm wants to cross this way. Um, this motor already is maybe going to start impacting some of these motors. So I try to keep this as flush as I could, but these two motors might have to go. They might be crashing into some of this stuff, maybe. But you could code it to be mindful of that when it moves its arm this way. But it needs to be able to reach forward and across without bumping. So that's a concern I have. I could make the shoulders a little broader to kind of get more space in the armpit region. That's something I might do if needed. That shouldn't be too hard to pull off. Since the shoulder girdle is formed by the collarbone and the scapula meeting with the humerus, you could just make a bigger scapula and collarbone, or move the scapula away from the sternum outward a little bit more. Now, you probably need a bigger collarbone so it can still meet with the sternum, attached to the sternum. But the scapula could just be moved outward away from the spine a bit, I think. Although it looks like it connects with the spine, use that as a pivot point. So maybe it would just have to be a bigger collarbone and a bigger scapula. See, the human body is so well designed, it's like you can't get away with much change without screwing everything up design. So anyways, yeah, if those are made bigger, those two bones, then this shoulder could be moved outward, then you'd have more space in here. But these crumple zones, so like you guys might look at this and say, like, there's tons of space to fit more of those teal boxes where the pulleys will be. Well, no, not with the crumple zones factored in. A lot of the empty space is crumple zone space. Plus, a significant amount of empty space needs to be reserved just to put all the motor controllers for all these motors too. There's going to be a ton of motor controller components that have to cram in wherever the space is available in between little irregularities in the geometry. Like here's a little area that motor controllers can be put and stuff. So we can't cram too much. So that all having been said, you can't really, this motor in our example, if you already have pretty much all the pulleys you can handle with the forearm, and we pretty much, let's say we can fit some more pulley systems, the teal boxes, into the bicep area. But eventually, the next really available spot where we could fully put more pulley systems would be like maybe like in this region here. Throughout here, we could put more pulleys against the outer ribs, where kind of the lats would be. We left quite a bit of space there to be used. That could be used pretty well. So that would be like a real saving, helpful thing. But, okay, if we're going to be doing the down gearing for this motor in the lats region, then that means it has to travel a long way with this power transmission. The cable that it's driving would have to go up, around, over, down into the lats, be down geared here in a little teal box, which represents the Archimedes pulley system. And then it'd have to run back up through the shoulder, all the way down with the higher forces now, because it's been down geared. So it's going to have like 27 pounds of pulling force. And that's a lot more rubbing and just a lot of oomph, a lot of strength being pulled through, scraping on the walls of the tubing. Since it's been down geared, it's going to be really pulling hard. And that's going to be a lot of rubbing, especially making turns with that type of high torque being put on it, going straight out then to the hand. So to start here with the motor, go all the way up, go into there to down gear, then go all the way down to the hand, that is way too much routing for the cabling, in my opinion. So then you want to have the down gearing for a given motor between that motor and where its final output's going to be. So if the motor's here, the down gearing's here, and then it goes to the hand, all in one shot, not going away from the motor, down gearing out here, then coming all the way back after it's got down geared, then going to the hand. So we want the motors to be further away from the hands than the gearing for that motor. So the gearing would be more distally located, the motor would be more proximally located. Which means a lot of these motors, in order to achieve our around 45 total down gears for the hand and wrist region, are going to have to be removed from the forearm region so that we can put 45 down gears in the forearm And so basically we're gutting a lot of the Forearm's motors. And because this is already full of motors, what we're going to have to do basically is delete the motors in the Forearm, place them maybe here in the lap area, and then assign the pointer pointing to them to one up in here, and then assign the pointer that was pointing to the one in here to the latimus. So basically that's a quicker way than physically moving this motor to here and then moving this motor to the latimus and moving the pointers twice. In this case, we just delete these, move them all to here, and then reassign these ones to here, and then reassign these ones to here. It's just another way of doing it. But the point is, it's a shift, it's a domino effect. We're gutting these and making these ones do the work of these ones, and then we're gutting these ones, making them all here or whatever. As long as they're the same size, it can do that. So basically, we're translating motors that, or we're moving these to here and then moving these to here. Essentially, even though I'm doing a kind of a funny trick way to do it, that's essentially what it is. We're migrating. Okay, so in order to describe that clearer, to be more concise, we're migrating the motors that are placed in the forearms to the bicep region, and then we're translating the bicep region motors to the latimus dorsi muscle region, because we can't have the motors that used to be located in the arms all be in the arms while still accommodating all the gearing needed for the motors. Since we want the gearing to be located as close to the joints that the gearing is responsible for as possible, in order to limit power transmission cable driven losses due to friction, the motors are what have to move, not the gearing. The gearing we want to stay in the forearm, and we want to increase the amount of gearing we can cram into the forearm, moving the motors away instead. So all this precious space that we're saving in the torso for other jobs, we're going to have to unfortunately take away for this purpose to go into effect. This is the sad story of just our available space that's left for emergency use only, starting to be gobbled up already because of real world constraints I'm running into with just struggles in establishing the required degree of miniaturization to pull this off. Another issue is, like, I tried cramming way more pulley systems in the forearm, but then I realized the forearm is really not that beefy on a human body, and especially now that I'm trying to make the design a little bit more usable, not just for a beefy male body, but also for a female body or a small male body, in order to have it be a more universal design others can benefit from. I can't just say, okay, if we don't have room, I'll just make the forearms enormous like the biggest NFL player. And that way I'll be able to fit it. But if you do that, if you start taking those types of kind of shortcuts and cheating, you're basically ostracizing anyone that wants to make a smaller robot or a more slender humanoid design or more skinny looking robot. You're pretty much making them unable to use your design then. So I prefer to try to make it more of a universal design. And so this is what I'm forced to do. So yeah, it's kind of a pain in the butt, but I guess it's not that bad now that I've said it out loud. However, like, what's freaking me out is, like, if I'm already having trouble down gearing everything for the hand, how am I going to down gear like all these motors in the legs? Where is all the down gear going to go? That's like technical debt I have now. Like, I designed all of this assuming the gearing. Well, actually, one thing I kind of had in my mind is that I probably wouldn't have to gear everything. I thought some motors could be used without down gearing. That was just a noob mistake. All motors have to be down geared, period. And so I don't even know why. That was like a brain fart to think a motor would not need to be down geared. The raw output of a motor without any gearing is almost not even useful. It's just insanely high speed especially for like drone type motors I'm using, which I had to use because of their form factor fitting the sleek, narrow form factor of the body. It has to be a narrow, long can size with a small diameter in order to fit in these types of spaces. It cannot be like the gimbal pancake style motors. Those don't fit. Those don't have the right form factor for a humanoid body. So these are just high speed, low torque. They need down gearing in order to produce useful torque and reasonable speeds. Those high speeds wouldn't be unuseful for a human body. They're way too fast. But the down gearing makes it perfect. So we do need down gearing every time. And to make matters worse, some of the bigger motors need even bigger pulleys, I think. Yeah, they will need bigger pulleys. Although, no, I don't know. I'm not sure. Maybe they. I'm not sure. I haven't thought enough about designing the pulley systems of a bigger motor yet. I haven't thought enough about it to say too much. But it looks like the majority of the motors even that I put in here are the same size motors as I use for the fingers. Only some of these like rare big boys like this are here and there, but there's not a lot of them. But we need like a dedicated area to down gear all this stuff. I don't see much room. Like I filled the thighs with this stuff. So like where's the down gear going to go for that? I'm just not seeing too much space. I mean, yeah, I see some space in here where the Achilles tendon would be. You can fit quite a few gears, down gearing systems there, but there is just like an insane number of motors in this thigh. So I may have to move like gut like half of these motors and stick it into this area along the spine. Like this whole area I left empty as emergency reserve area. I thought maybe I could fill that with batteries if I had that luxury later. But we may have to move like half the motors in the thigh to that region and then use this, like the whole outer thigh, to do like a million down gearing pulleys. And then, so we'd be moving like 35 motors out of the thigh and into this pelvic region behind the batteries, like where your intestines would be. Then we could probably do enough pulleys to down gear all these motors. And then we could probably, I don't know if we'll have enough room just here. I mean, it looks like we fit quite a few pulleys there. Oh, man, it's getting tough. Let me read the chat. I don't know if you guys are saying stuff in chat already. I've just been speaking out loud my thoughts. But it's just this down gearing thing has really kind of come back to bite me, or at least it's I feel like the down gearing, the fact that we didn't even model it out. Same with the electronics, like all the motor controllers, we didn't model out what they're going to fit. It's like I placed the motors, and I'm like, that's the hard part. Down gearing, I kind of forgot about, and now that I'm like realizing we need to fit a lot of volume. The down gearing is going to take a lot of volume out of this design, way more than I really planned for. And so I'm just really concerned about that. I mean, it's going to be a real battle to the very end, to the bitter end, to make this happen. And it's tough because like so many areas like this, you would think, oh, this obliques area and stuff. Like, oh, there's a lot of area here you can put stuff in. Nope, because if he leans to his side, this is a crumple zone. All these motors here are going to start hitting these motors if he leans too far to his left. So the crumple zone issue is a big one as he starts to lean left and right. We don't want to start losing too much range of motion if we want him to be able to do athletic and gymnastic type of things. We can't fill crumple zones with parts that make him unable to even bend side to side. He'd be too stiff. We don't want to lose range of motion. So these are more constraints we have to bear in mind as we go forward. So I figured about 45 I would be happy with, 45 down gearing systems. So I'm going to start out by moving these two motors out and probably these three. So that's 5 we can move out pretty easily and load in a ton of pulleys here where those 5 motors were. That'll be my first step. I'm just going to go one at a time. Okay, so that deleted, or actually, we're going to move that one, the same, to the Latinus dorsi. Just before, since we had nothing planned for these areas, there's like empty space, just like free space. This tubing wasn't like tightly hugging anything. It was just a deal with it. Now that we have big plans for this space, just bringing it all hugging. It's going to be a lot of moving things around, but this is like that's what I mean when I say like people say like oh, just design like only the hand or whatever, but you can see how like even the routing of the cooling system lines is affected. It's a domino effect. If you want to change anything, you have to change like a million things. And that, so it's like you don't get to design just one part of the road. You have to constantly be factoring how everything changes the entire thing. Adapting accordingly. So basically, I'm just clearing out space to try to cram as many motors as I can back here. Now, there are people that are going to really like this change. There are some big upsides to what I'm doing, which was kind of forced onto me, and it's just going to just be a blessing from God, really. Because, check this out. By moving a lot more of the motors out of the arm and into the torso, you are lightening the weight, the thrown weight of the arm, it's called, which lowers the moment of inertia, or moment inertia. As the arm's moving forward and it wants to stop, it won't have as much mass to stop because there's not as much weight in the arm. So the thrown weight is less. So it'll be easier to stop the arm mid-progress when it's going forward or backwards. So that'll make the arms able to be quicker. Another benefit is the amount of actual routing from the batteries to the motors out here. It's a lot more cabling, but since the batteries are located in the midsection and now we're moving a lot of the motors to nearer to the batteries, that's less heat developed because of less transmission of power distance. All electrical circuits, or the copper routing, the more length you have, the more transmission, like friction of the transmission of the power is there, which generates heat because it has some electrical resistance. So we're lowering electrical resistance, which means less wasted power in the form of heat from electrical resistance. So that's a benefit as well. Also, moving the motors more toward the torso probably just generally gives a little more room for motor controller, since the torso, generally speaking, it just seems like a little bit more volume to play with than the arms in general. I made these arms pretty muscular, pretty bulky as is, but for a female robot, for example, there would be hardly anything you could even put into the arms, components-wise. If you start feeling around on your arms, you can pretty much feel bone everywhere you squeeze, like your forearms. There's like just bone. It feels like there's barely any muscle in the forearm. Even for me, a pretty strong guy, there just doesn't seem like a lot of muscle. Like around the wrist and stuff, it's all bone. So I don't have a lot of room around the wrist to place like pulleys and stuff. Which meant I was just putting pulleys like basically just in the back of the arm, like here. But I need some meat to put the pulleys. Like where actual large volumes of the forearm is, I gotta fill that with pulleys. So that means some of these motors got to go. So I got this really crammed up in here as close as I can to these other guys. Obviously, it could get closer, but I think that's fine for now. So that's one down. Now, where that was vacated will be a little pointer, which is this thing. And this pointer leads you out to here, and then it leads you to here. Points to it's just slightly past me. So that was handling this particular. Oh, all right, let's do that again. When I selected the muscle, it selected every muscle. We don't need to select every muscle. Okay, let me try that again. Basically, you're seeing how these little black pointer systems work, so I can figure out what motor is attached to what muscle. So anyways, back to what we're doing. Okay. What is this sticking out here? Huh. It's probably like the tricep or something. Oh, it's the supination of the radius bone. Anyways, so this motor we just moved. We're going to be able to backtrace what muscle it goes with. So do this. And we can highlight this one. Takes us to this muscle. Which one is that? Okay, so it's for bringing the thumb across, or like rotating the thumb this way. Just showing you guys how it goes. So anyways, so that then, we're going to assign that tip, which now doesn't point to a motor since we got rid of that motor. We'll assign this one to somebody like up here. Yeah, something like that. I'm glad we're doing this. Basically, like, we're cleaning up kind of our rough draft. I thought it was more final than it is, but we're cleaning up oversights and just lack of experience, lack of knowledge from like our original design. Playing cleanup here. So the motor replaces over here, so alright, so we gotta put insert edge loop tool. We don't want that string passing right through the arm. Okay. Alright. I feel good about that. That's one down. That process wasn't very painful. We just got to do that one motor at a time, clearing out, gutting out the forearm little by little. And as we do that, we'll be able to start putting pulleys where that was. Think so? Right? What's it used to be? Wait. Alright. We'll be able to repeat that a lot of times now. Where's that 6 and 8? We got 19 pulley systems in the forearm now. We want 45 we estimated before. Actually, let's see. Is that possible? Picturing the forearm bending like a bicep flex. So we slide the hip there special. We don't slide this too. Wow. But I think we do. Yeah, let's see. Oops. Okay, I think I got 6, 4, 5, 6, 7, 8. Here. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, getting there. Okay, so we just put these through this motor because this motor's going away. So it goes here, away, here. Like any place we have room in the body at this point is like a treasure. That's why I'm like trying to hoard the space best I can. Because once space is filled with components, that's it. And there could come a day where we're like, oh, we didn't consider that, or oh, we didn't consider that. Like, oh, we need a bigger power supply volume than we thought. If I'm filling all the available space with stuff, there could come a day where we were like, we cannot fit this component at all, even if we shift things around a lot. We're screwed. And I don't want to get to that point. The more space I can leave unused, the more late in the design phases where we find out, uh-oh, this bicep motor is not going to cut it. We need something twice as big. We can like shift things around and arrange it to where we can have something twice that big so that the bicep can be made big enough. As long as we've got room to spare and move things around. But if everything is so full that we can't do that anymore, then we're going to have to start like having to say, uh-oh, we can't solve this to certain problems in the future. Like this problem was out of nowhere. Like, wow, we need way more room for down gearing than I ever really thought about. And we actually have to down gear every motor, not just some of them, but every motor needs down gearing. And these were just things I didn't grasp the necessity for early on. When I was designing and thinking about this, I just, for whatever reason, I just thought motors don't need down gearing all the time. But it's not true. They always do. So, little oversights like that, I'm sure, are going to keep happening. Like, stuff down the line. So I'm just like, always thinking, how can we miniaturize, how can we fit stuff in such a way to still save some of the space we have remaining. So I'm hoping to still try to put nothing into the upper ribcage region. Above this computer, I want to put nothing where my camera is right now. All this space is a lot of extra space to use for stuff. And we were able to get that by putting this big red bag and these bags here. There's 2 bags in the stomach. We moved those from this region, clearing out this space for now it's free space. And another thing is like, if we want to do like 100 different facial motors or like 100 different muscle actuations for the face in order to have really complex facial expressions, we may not be able to fit all the down gearing and motors needed for that into the skull. Yes, that's a lot of space to work with, but when you factor in the USB microphone and speaker set that I bought, that's going to fill like a significant amount of the skull right there. And once you start adding in all these motors to handle all the facial expressions and the cameras for the eyes and all this stuff, it's going to fill up real quick. And what if we don't have room? Then if worse came to worse, we'd be able to use this upper torso area for the motors to handle all those facial expressions. So I really don't want to fill that. Or what if we needed more room for the power supply or way more batteries on board? And we just way undershot the amount of batteries needed with these batteries I put right here. What if we want like 5x that? We need to fill this whole area with batteries. So there's just so many questions and things I don't know, and I'm just hoping for the best, kind of like guesstimating stuff as we gather information. Okay, just want to stick right here. Too much. But these two, hope to the last. First, substitutes. Let's see, it came to right here, so following it back. Oh, the side to side of the ring finger, like the wagging motion. Okay. So that's going to be all the way in the latimus dorsi. Wow. moving. I mean, that does not need to be a strong area, so whatever power transmission losses we get from that long journey is not a big deal because it doesn't need to be very strong. That side-to-side motion is a weak motion of the body. Yeah, these are super weak muscles. Let me edit match this eventually. It's so funny now. We've got actually finger actuation happening now, whose motors originate in the latimus dorsi area. Really goes to show you, this is just a lot of complexity with the hand, to where now the actuation of that is spilling out all the way into the torso, throughout the arm, just all the components involved, everything needed. So this is why people skip making hands for the robots. They build really nice arms, and they don't know what to do for the hands. They just put a stub there, and then they end up with like a single motor gripper or something. We don't want that. We want it to be as dexterous and capable as human hands, which are a marvel. That's what we want. Human hand level capabilities. Okay, so we've got 19 pulleys out of 45. So we still got to double it. Just keep going. Let's see. I like just doing these three next. But now that I feel like we just found a great way to handle this. I'm happy about this. Just moving all these motors the way we're doing it. It's not too painful. Object. Moving them to the latimus dorsi area. It's just there's so much room in the latimus dorsi area that's not being tapped, and it's not really an area that I felt really connected to as far as like really wanting to preserve it. It's being precious to me because it's a narrow, very thin area that's just hugging the side of the ribcage, and it's not like a very useful area where you can put like a large power supply or something in it. It's not a huge area as far as like width, height, and length all being combined. It's not like a nice box shape where you could just fit a big item. Like we can't even fit big motors in this region. But these smaller finger motors, we're able to fit here, no problem. So we're utilizing an area that wouldn't be like universally useful for much to solve our problem. And I'm really excited about that. This is great. So now we can take these two, and we've got to group them. Okay. Man, am I glad I did this CAD work myself. Because, like, with the amount of changes I'm needing all the time, I would hate to have to go onto Upwork and, like, hire somebody to figure out. Oh my goodness, it'd be a nightmare. Okay, we'll just put it on this motor here. this one, we'll slide over to. Wait, what is this one for? Goes here. For this muscle? Ah, it's a thumb muscle. Makes the thumb go outward. Like to lift the thumb that way. Interesting. And that one we're going to slap all the way around. Need to put a insert edge loop tool there. Major changes today, but not as painful as I thought it was going to be. This is really not near as bad as I thought. Like, this is going quick. It still is, though, like, generally a scary thing to me. How much space the pulley systems are taking. When you consider that there is just so many motors on this robot, and there's going to need to be so many pulley systems there. And it's like we're solving some of it for the hands. That's just the beginning of the nightmares to come. So, hey, why is my... Do I have any viewers right now? My chat's been completely dead, and I've been streaming for... I have one viewer. I've been streaming for an hour, and I have not a single message in chat. That is really... Not ideal, but okay. So that's taken care of. Before I clear out too many more of these, though, I want to actually populate the space with pulleys. We're going to be able to fit all the lot. Wow, I mean a lot. Well, I guess we could start out just copying these four. I guess I could just... Okay, I got an object mode copy. I'm going to group, and then I'm going to file, export. This will bring us up to 23 pulleys, just this copy alone. 23 of 45. That is really started. Looks like we've got plenty of room to keep going outward, you know. Yeah, we could stack him. Fight. Yeah, come on, please. Just like that's fight. That's good. I think this one. This one's awesome. It's like a choose like it was recently. That's good. So I got it's 25. Most of these are good. Let's see what this one went to, just curious. Ooh, this is the grip of the thumb granted that way. I think we assigned 2 motors to that, just to make it doubly powerful, because that's very important on the grip. I did little things like that to bless myself later on. So I forgot about it, but I knew like I'm going to make this thing. If I assign 2 motors to some muscles like that, I need to be really strong muscles. I'll be dancing later. So. Such a big redesign is like intimidating. I guess like the way we're handling it worked out great and everything went smooth, but it's scary to think like that we could be that far off. It's scary to me. And it's a good thing also, like think about this. With this big of a redesign, imagine if I had put all these motors into that already. And I'm now having to tear this all out. Because I considered doing that, attaching all the motors, but worrying about gearing later. If I'd done that, I would be like literally having to start over to such a tremendous degree. Oh wow, I inadvertently I didn't assign this to a motor here and then assign one of these motors to here. I just moved it and assigned it to right there. Period. Skipping that intermediate step. I guess that's fine. I'll just start doing that. That's going to save me time. Because ultimately, it turns out like most of the smaller motors in the bicep area, anyways, were for the fingers. So why move a finger assignment motor to a finger motor and then that finger motor to here when you could just move the finger motor and its assignment just straight out here? So I'm going to do that going forward. Now that I know that most of these are finger motors anyways. It's so funny that the finger motors are like in the torso. That is just nuts. Oh, and now this is starting to clip a little bit. Can you go here? Without clipping? Okay, then we can't go here or here. We gotta start the next row. Up here. That's scary. It's so funny that we're moving these motors so far away. This is what needs to be done. I mean, the pulleys for these can't be where I'm at now, where the motors are closer to the hands than the pulleys, as we went over at the beginning of the video. You want the pulleys to be on their way to the fingers. You don't want the motor here. It has to travel way out here, do the down gearing with the pulleys, and then travel all the way back. You want as little travel as possible, so just a one shot is better. Just send the transmission through, have it down gear here, and then make it to the hand. That's the right way to do it. So yeah, this is very interesting how this is working out. Okay, where was that motor at? It was right here. And we'll put these. These ones, what? See? These ones. Oh, I see. Okay, these are. Okay, so two go to the motor. Ah, okay, so one is bringing the thumb out and one is bringing the thumb back in. Two go to the motor because the motor has forward and reverse direction. Got it. So a lot of the motors handle forward and reverse direction on the joint. But we were noticing a lot of them are just handling a single muscle, not the opposing muscle as well. Which means less pulleys. You just need one pulley system instead of two in that case if it's only handling a single muscle, but not the opposing muscle. It just needs one pulley. Okay, so that's moved. Okay. Nice. Alright, we've got 25 pulleys. We still need to get up to 43 pulleys. Looks like we can fit a pulley right here. Oh, that's not over. No, it's not. That was pulley 26 of 45. Well, we rounded up to 45. Let's just say 43. 26 and 43. We need 17 more. I already attached this motor. So I'd rather. I should buy this. 2, 3, 4, 5, 6, 7, 8, 9, 10. These ones. And there's 3. like second. So weird. First. It's just so weird. I've had this read out for years. Thinking that it's gonna be like nice to go. So you know, it's like, let's go. Here we are. That's something going. It's just so weird. Let's run. Looks like we're running out of space in the lab in this Dorsey region for this stuff. That's scary. I really don't want to start going anywhere else. We're already taking up so much valuable real estate. I don't want to have to go much further. Encroaching on other areas that are by all for the hands. Well, we gotta hope that these hands are worth it, man. They better be awesome hands, because they're causing a lot of grief to the whole robot design. They're just sending motors everywhere to make it work. Definitely makes me appreciate human hands, how they can fit all their actuators in such a small area and yet be so strong. Their actuation is like all for muscles in the forearm. And yet, if you look at your forearm, it doesn't even look like you have that much muscle there. Yet to match that level of muscle, you need to fill the whole forearm with gearing, and then most of the bicep area and even the lat area with gears. It's like just crazy. Just to make the hands work. Okay. Found some. Get up there. I'm gonna of. Just move on to it. Okay. It's on. It's on. It's just crazy that the hand actuators are so far from the hands at this point. Oh my goodness, it's weird. I don't like that. That would interfere with the swing of the arms. Um, uh, at the very beginning, we chose to not move this motor that close. It turns out that was kind of a mistake. It needs to be close. And this one actually swing. Like that. Okay. And once I split that. I'll pull this before that. One thing's to do. So this is the first one we're seeing. So it stays there. Yeah, there's Also work. Okay. Seriously. What's up? What's up? What's up? Here we go. What's up? What's up? What's up? Okay, so what's this? What's up? Oh, okay. Okay. How handles what again? Oh, tip of the thumb. It's a long way. Tip of the thumb is in the middle of the back. Well, it's only got to make the one turn, and then down gear here. Should be fine. Okay. So now we can pack a whole bunch of pulleys. Um, I believe this is pulley number 26. Where's my son? So how do we get this over? How close is it? Sweet. Pretty close. Yeah. That's good. Okay. Wait, hold up. Good work, Stace. What do you want? Okay. Good. These eyes I can see. Who do? I don't like how complicated that might get at the elbow joint. I'm gonna keep the forearm components in the forearm and just leave this empty. Because that's like a what do we call that? A crush zone? It's too much of a crush zone. Oh, I got some chatters on here. What's up, bro, Richard? My robot will doom the future. How do you? I don't think you will. How do you? How do we know where you were? But if you don't, I don't think the robot will be back to it. I mean, well, it's supposed to be all part, but I don't know. I think there'd be little giveaways. See, my anticipation is like, even if I get it pretty convincing, it's still gonna be like, if, like my goal would be if the robot could trick somebody to think it's a person for like a few minutes from like a little bit of a distance, but there's no way it could like pass completely for a whole stream or something. I mean, maybe for somebody that's not like looking for it, but if you're looking for it, you'll probably find some kind of thing that's awful. Okay, I think we have 30. So yeah, unfortunately, it looks like these four motors have to go too. Oh my goodness. So we still don't even have it all. What the heck? My goodness, that's nuts. Wow. That's. Oh my goodness. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. 32. Let it go. Oh, that's what. That is good. Yeah. Oh, it's actually settled. That's pretty. That's important. Oh, yeah, yeah. Can I those? Positive gas message. This is the first bigger one actually. You back with it. Yeah, exactly. Yes, here. Okay. Okay. This is nice. Finish. Definitely not. This card has to have this time. So this one's back. This is this goes to this one's next. Pretty sure. Okay. So that. What's that? I'm not myself. I'm not saying something. Try. Losing points. So much as also try this out. He's still like that all the time. So, okay. So I'm gonna basically do the entire board kind of simple. Just this is nice. Oh, maybe it has a let's try this. Let's see. Oh, I've seen it. So, oh. Hey. Okay. We all also. Might be. Let me know. We can go back. Uh, I'm done moving motors, man. Can't do it anymore. It's devastating. The more motors we move to the torso, although there were those upsides we discussed, it's still encroaching on space we're going to need later. It's like you know what this reminds me of? Like if you're about to go on a Lord of the Rings distance journey and you're eating all your snacks like while you're still in the Shire. It's like, yeah, the snacks are good, but we're not going to have food left at this rate. We're not going to have space left at this rate. We keep gobbling up space that's greedily. That's how I'm seeing this stuff. Where's this Nintendo? What's up? Like the worst case I have on device is like what happens if I was on my game. I got margin error. So something goes wrong happening. If I gobble up in space, there was no margin error. I was like, just get more to try to one. That's it. I see. So we go. Top of those are small. Okay. Oh, oh, that happens. Ah, this is actually nice. Let's get comfortable with it. You come up. That's great. I think we can do let's see. Is it personal right? I think we can actually put two or at least. Oh, we have to do this too. Oh, that's too. Nice. Oh, that's good. And I think. Do that. That was good. And so, what will work? Yep. That happens. That's good. Okay, let's go count. One second. 2, 4, 6, 8, 10, 12, 13, 14, 15, 16, 17. Actually, count those dimensions. Do all the numbers. 2 are numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, okay. 20. Oops, 8. That's wrong. 2, 6. Oh, that's wrong. There's only this part. Or, isn't it? So, yeah, okay. Come on. All these groups are going to count. That's right. That's right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Yeah. 36, 37, 38, 39, 40, 41. Oh, yeah, so 40 numbers. Okay, fine. So this means you got to keep 2 numbers. That's it. Yes. This is the liquid cooling line. We don't need it to go all the way to the bottom of the arm anymore since we took all the motors out of the arm except these two as far as the lower arm, forearm section. Now the air cooling line here. Right? Something like that, something seems to be under translate. And we have no less percent of those services, something way down. Systems. So, this week, let's see. Ace, maybe start again. Maybe, sure. Okay, that's fine. Let's go out, please. Granted, some appear to be in the crush zone here, but I think that the pulleys, like muscles, because it's just string, will actually move out of the way when it wants to be crushed. So I think they'll be confined conformable or compliant or whatever. It's like these will move that way, and these will move that way. Just like a muscle will move out of the way. It's just they're not like rigidly attached as much to anything major. It's still going to be very difficult. I keep wishing that I would have put this more in the T-pose, like the arm out further. Because every time I have my camera in here trying to look at the inner forearm, I'm like clipping my camera into the body. And that sucks. Then I got to zoom in more. But I don't want to be zoomed in. I'd rather be zoomed out like more to here. So it's hard to design the inner forearm area. I've been wanting to move this out for so long. There's so much stuff to highlight or select in order to rotate it out. It's like a nightmare job of trying to rotate this out at this point. I don't know if it's worth it. I'm getting by, anyways. So basically we had to move all these guys out here and these guys. So like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 motors we moved out of the forearm in order to pack a gazillion pulley systems into there. Is it the end of the world? I guess not. But it's foreboding to me because it's like, where are all the pulleys going to go for whatever this stuff represents? Although I think a lot of these are represented by these pulleys. So like, probably half these motors are being down geared right here to work the hands and wrists form. And all, like most of these are, or all these are too. So that means a lot of these won't need their own pulleys, and some of them only need a single pulley because they're not working two muscles, whereas a lot of the ones for the hands are working two muscles. There's so many muscles, forward and backwards, so many things going on in the hand that it needed more pulleys. But maybe just for these, we might be talking like, let's say this is like 10 motors, and each one is primarily just doing a single muscle actuation. Hey, why is this one gray? That ain't great. You know what though? So like, let's say this like 10 pulleys. I think already we might be able to squeeze like 5 maybe just around in this area in general. Maybe. But check this out. Like in through here, like this area, will have a lot of room for pulleys. I think. Even like in between the ribs. A pulley, maybe another pulley. Like in between the ribs, I think we'll have a decent amount of pulley space. Even same here, like, well, yeah, maybe like pulley. Although, one thing we have to bear in mind is we're going to need, like, right here at the seam of the ribs, formed by these bones meeting. This whole thing needs to open like a door for us to be able to work inside the workbench. So I might have like a hinge system, and then this will all be attached, but then you can easily separate it, maybe like a clipping system where they clip together, so that we can swing this out like a door. And all this stuff needs to be able to swing out like a door, which is being prevented by this pipe, which I don't like. That would be a good time to address that. Well, no, this. So long as the pipe's over to the side, I guess we could swing it all this way. And then this pipe would slide out here, so that we could just like swing the whole thing, slide the pipe all the way to the crevice here, and then swing this whole bag off to the side, like out here, for both bags. And then we'd have access to the batteries then, which also would be able to swing open like a door. And then we'd have access to the whole insides, including the computer and stuff. So throughout the whole time, we have to be picturing, like for maintenance, how to open it all up to access everything. There could be nothing that's unaccessible. Everything has to be accessible for repair and maintenance. It has to be. So it has to be like not too hard to get to things. Anyways, without this thing, we're kind of naked. We need to be able to see what room we have left. And this thing shows what room we have left. Really nicely. So I am grateful for it, even though it can feel kind of in the way at times. Let's see. Nothing's clipping it at all. Everything's within that base mesh. Except, that's weird, randomly the scapula is clipping. That's weird. I never noticed that before. Oh, this is really big squares. I mean, this would just be rounded out a bit. It's very low poly right here, so I'm not worried about it. Alright, well, we solved the problem. Now we got a gazillion pulleys in the forearms, which we're just kind of not very impressed with as far as the space they give us to work with, since it's mostly all bone in the forearms and just very little muscle. It's really flat muscle. It's a muscle that's moving around. And there's this zone in here where when this pronates or rotates inward toward the body, this is a crush zone. So I had to keep it mostly clear for the motors and stuff. But now we were able to fill the crush zone a little bit more with the pulley systems, because I think that they will move out of the way. And it does pronate like that. Okay. Well, that was a big change. So, luckily, I only had one motor on the physical robot so far. So, as far as the pulleys, we've built this one to about 90%, and that's why I was able to get the bigger sizes for the system, the pulley system that's represented by this teal box. With the bigger size, everything had to be scaled up. And I'm like, man, we got to model out where all these are going to be. So now we finally did that. We respected that we need a lot of space for the pulleys. And my idea to just have the motors all in here and fit as many pulleys as we could didn't work, because we weren't able to fit near enough pulleys in this area. And the overflow pulleys, in order to handle our need for additional pulleys, would have had to spill into here. But now we have motors down here using pulleys up here to actuate things down here. So then the motor's going up, down gearing here, and then coming back down the round trip. And that's a lot more cabling. We'd rather have the motor be more centrally located, the pulley on its way to the joint it's actuating. So this is like a big time intersection point, this forearm, for where all the motors throughout here and even here and a little bit here are all aiming to actually this hand. And this is where all the down gearing occurs for that. And since a motor like right here that's actuating a finger is not down geared up till this point, making these turns and going through Teflon tubing should be very easy on the tubing and very little friction because it's mainly just pulling with no effort. Like there's a super low torque and just high speed. And since there's no torque on it and no resistance, it's not really doing much. It's just gently pulling through. It doesn't pick up torque and power until here. And only after it's picked up torque and power does it then, during a turn, it would really press hard against the Teflon and create a lot more friction. So just making the single turn and then passing through the elbow is a slight turn as well. We'll have to give some slack to make sure it can make the full turn. When this does like a bicep curl, whatever cabling goes through here, we need to make sure there's enough slack that it can get through here and be able to still make the turn. So there's going to have to be some slack in here during the cable routing. That's going to be interesting. But yeah, making the one turn for the elbow and then the other turn for the shoulder. Just two turns, but since there's no down gearing prior to them, I don't think those will add a tremendous amount of friction. It should be minimal. And then the big friction is created only after you down gear. But by that point, it's just a straight shot for the most part into the fingers. Except you do have to pass it like through, or maybe wrapping around or whatever to get to where it needs to be. So there will be a little bit of rubbing there. It has to be a little slack for when the hand bends a lot. A little bit of slack maybe. It must be routed through here. I don't know if you need too much slack if it's routed through the front of the hand. Not sure. Maybe not as bad that way. You go through the front and then wrap it around maybe to do the back of the fingers. I'm not sure. But it's crazy how like the design in theory changes so much when reality starts to hit and like you realize I'm panicking about pulleys and stuff like that. Yeah, we can fit it looks like we could probably fit some more pulleys in here. We might be able to do like 10 through here. Maybe fit like a few pulleys there. Maybe like total like 13 pulleys in the upper arm. Probably fit maybe some pulleys in this area. But this is a real crush zone too. I'm concerned about. But maybe like 4 pulleys could be up in here for pulley systems. When I say pulleys, I mean pulley systems like this teal box representing the Archimedes pulley system that we've talked about a lot in this channel. And then a lot of pulleys can fit all throughout this space between the ribs, even between the ribs, but also outside the ribs, between the outside the ribs and the skin. All through this region can fit pulley systems. And that will help for like the pulleys for the shoulders and stuff, and biceps and deltoids and all that. We can fit pulleys through here and so I think we'll be able to pretty easily control this whole shoulder girdle area and everything involved with that. And the neck pulleys, neck system. Actually, where are the motors for the neck? I don't even know. Let's just take a random neck spine and see where the motors are. Okay. That goes out to there. Okay, that's the label for it. Where is the motor for it? That'll be this one. Okay. Let's do vertex. This is a neck motor selected at random. That's not good. I'm assuming. Okay, yeah, yeah. Oh, that's fine. They're just not as close together as I'm used to. Let me disconnect. Oh, wow. This is the motor to actuate that neck, and it's in the butt. It's in the gluteus region. Wow. That's for the neck. That's very unexpected. Wow. So I just did not want to put any motors in this area for whatever reason. I just felt like there's too many muscles going through, whatever. But pulleys can definitely, I think, go through this without too much worry. Yeah, pulleys should be able to thread through all those muscles everywhere. So yeah, we'll be able to fit quite a few pulleys in there. And the key, like I said, is we're just really concerned with trying to keep this area inside the ribs and all this area inside the ribs. All this area clear of anything. We don't want to put anything in there until we have to. Because that could be a key spot for like putting a big power supply or a ton more batteries. Because I want more batteries. As many batteries as I can get in here. Same with this area too. All this area where the intestines would be. We already had to put some motors in this region to replace some of the brushed DC motors that we used to have located in this area. We had a ton of them. And since we got rid of all brushed motors and went to bigger brushless, they had to spill over to the inside of the pelvis area. So we already started using this emergency space, which we don't want to use, but we have to when it's needed. So it's on an as-needed basis, but we want to avoid it. And we can't go much higher here because this is a crush zone. When the body bends to the left, this will all crush as these come down. It will all rotate this way. So if we want him to lean to the side, this can't be full of stuff because then his back will be stiff. He won't be able to lean left and right. That would be really bad. He already might have lost flexibility like a gymnast and the ability to lean to the left just from the smallness of the crush zone as it is. Unfortunately. But it doesn't look too bad. Because it's not like it just leans right here. The whole spine curves to the left. So he should be able to curve the spine like at this angle. It's pretty good lean to the left. Yeah, like the pulleys for the legs, like I said, that's going to be a real trouble. And that could be where we have to start moving like 25 or 35 motors into one of these precious areas that are porting like into this area. We may have to move up here in order to free up enough space along the femur to put like 30 or 40 pulley systems in order to down gear all this stuff. We need a lot of pulleys, a lot of pulley systems. So some pretty serious measures are going to have to be taken for that. Since our focus still, like it's funny, you can't really focus too much on any, like I just want to make the finger move, but it's like, yeah, well, that's a lot of motors just to handle even one finger. And where are those motors going to be? Where's the down gear going to be? I mean, you have to kind of design system-wide thinking, not just focus on one thing, tunnel vision, because then there's too much interrelation between everything. Like as far as spacing, general location strategy and stuff, there's so much going on there that you kind of have to be designing from a bird's eye view and not get pigeon or tunnel visioned on like one specific problem, like a number that big. This model does look really good though. Pretty broad shoulders already. Maybe it could be a little bit broader. Well, that's kind of broad already. Looks like a pretty stout dude. But it's a lot shorter than I wanted. Like, this is only like 5'10" or something. I wanted like 6'4", much taller. If you make it taller, you're gonna have a lot more room for parts. So I want to make big robots, but since right now I'm using PVC medical skeletons, I have to make it 5'11" because that's the size of the medical skeleton, and I don't want to build bones for my first robot. My first robot will just use the PVC medical skeleton as the bones, and then that robot will build the bones of the next robot out of fiberglass, and at that point I could go with a nice taller robot with more room for stuff. But who knows? I might just make them all 5'11" PVC. No, I'm gonna want to make one taller for sure, at least one or two. It'll be fun to have a taller robot. What's up, Twicep? Long time no see. Weird schedule. Yeah, a little bit weird. Yeah, I'm going by Larry. Trainer, what's up, Trainer? Okay, so that's my update. I made the big change. I just wanted to record everything for this. This is a very big change for my robot design. But I'm glad I did it now before I already put in all the motors into Forearm. You can see there's only 2 motors in the Forearms now. And I used to have way more. Now it's only 2. And all these teal boxes are just the down gearing, Archimedes pulley down gearing systems. Alright, so that was big, big, big. Big, big, big. And as far as the Archimedes down gearing pulley system, I've got a bunch of little tweaks to make. I don't like the way I made the pulleys. There's some problems with it that I'll be showing in another video. But I think with a couple of minor modifications I can get it working. And hopefully we'll have our first down gearing system done soon. First of many, 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 many. And I bought a bunch of tools for it too. Actually, I should stop this and start this room and make another video to talk about this. Alright, so peace out. Let's stop this video here which covers this. We're going to make another video discussing that stuff. Alright, peace out, guys.